So study sheet entry, okay? This I would put it at the top. Study sheet entry. And I'll do one better yet. I'm going to go to the front of this booklet, and I will write on that booklet, because let's say you're making a new study sheet, this is January, and you grab this booklet, I would say go to the front, and pages 1 to 15 we dealt with probabilities only. Pages 16 to, let's say, 25 is odds and probability. Like I started with odds and then I kind of mixed it up. Remember, did I tell you about maybe to remember that odds need to have dot dot? Is that going to help you remember? Dot dot, the two D's. So odds should always be stated like this. Probability, you should always have a fraction like that where you have a number and another number. This bottom here is total. Okay? Odds do not have total ever. Like you never have all possible outcomes on any of these. Okay? That's very important to remember. I will say page 26, review probability and odds. Okay? Study sheet. This is, to me, probably the one that summarizes best what it is that we've done so far. All right, so I've helped you out here. A deck of cards is on page 4. It should also be on your study sheet. So let's go to 26 here real quick. And it starts with odds, right? You have to make sure that the question always says odds, and it has to follow with some sort of indication whether it is in favor or if it is odds against. And in favor could be replaced with for, of, any of those, but that's the main difference, okay? And also that you can have it, like I show you 3 different ways of writing it. You could either think of favorable outcomes, not favorable, or for, against, or right, for is A happening, that event, and A not happening is, so it's happening, not happening, okay? Maybe it's happening, and this is not happening. That's odds for you. And odds against is basically the reversal. Watch. Favorable is here. When it's odds against, you want like that event on this side. For is on this side, or the event actually happening is that on that side. So you technically go not happening here. Not happening. And happening. Okay? That is probably the first thing. So here's where I'm going to add some more concrete odds of event. Okay, we write the event and then the event not happening. So one more time. But more importantly, to get the not, I go event to total minus event. So if the odds in favor of the Jets winning is like 7, right? 7-3, sorry. If the odds is 7 out of 10 games, then on this side I would go 10 minus 7. So that would turn out to be 7-3. Okay, so that's, I subtract whatever number I put first, I subtract it from the total. Okay, so if you have some kind of indication what the total is, I subtract it from it. Next, odds against. What happened here? Against event. We write watch this. If it's odds against the event, whatever it is, multiples of 4, rolling a 5, rolling even, odds, like whatever that event is, I put it down here. Okay? The event in question you then put on the right side first. Then I come over to this side. I go total minus event. Okay, so this basically, that's what determines what I'm going to subtract. Okay, so in a nutshell, the 7 to 3, if it says odds against winning, it would technically be 3 to 7. You literally just flip it. If it's the exact same event we're talking about and you're going against, you just flip it. Okay, next, this is going to be the other way around, going from probability, or like from odds to probability. Now, from odds to probability. So remember, if you have the odds in favor, then it will be event happening, event not happening. From that, you can get two probabilities. Probability in favor of event, and you can get probability against, or that it's not going to happen. Remember, it's probability, it has to be a fraction. The first thing I want you to do is add these two up to get your total. So we're going to go E plus E bar. Same with this one. Like that would be the number one thing. Remember, I would only ask you for one. I would probably ask you a probability of somebody winning, or it raining, or drawing a jack, or whatever. Okay? And then, so I would add first. So E would go on top in this case, if it's probably of the event. If it's probably against the event, then obviously you grab this number on the right, like that. Let's do an example. I think it would be nice to have an example here. Odds of drawing a jack. How many jacks are there? 4, right? So on this side, you would be tempted to go 52, correct? You're almost there, but unfortunately this is still a -1. You take the 4, because you've already used it. It's almost like you already used the 4. You cannot use those 4 anymore on the other side. Okay? So that'd be 4 to 48, and we're just going to leave it like that. We're not going to simplify it. So we came up with our odds. In this case, we were able to do so. You're with me, right? This is how many jacks there are. Therefore, 48 are no jack. They're non-jack cards. If I asked you for the probability of jack, first thing I would want you to do, or know that you should do, is this. Add them up. Add up those two numbers for the odds. That's your denominator. And we know that the 4 represents the number of jacks, so it'll be 4 over 52. And I'm willing to bet that you would probably be able to come up with this without looking at the odds. I know that. But sometimes they will just give you the odds and ask you to come up with a probability, and you need to be able to do that. Okay? Probability of not drawing a jack, or against a jack, or something along those lines. Guess what? You'd still add up those two numbers to come up with your denominator. And in this case, you'd put the 48 on top, because those we know already are cards that are not jacks. So that's a practical example on how to do that. I don't have room right now because this was on a different slide. I will show you that in a bit. But what if you were given the probability and you had to go to the odds? Like, how would you do that? And just think about it. 4 over 52 is probability of jacks. You would take the 4, right? You would take the 4, and then on the other side, you take your total and subtract the 4 you've already used. Boom, you're back to odds, right? So you should be able to see here how you went from here to there, but you can also see how you go backwards. Okay, so that's how you come up. That's how you deal with odds and probabilities. Okay. All right, let's go to 20. What was it? 22. Yeah. Let's do a few questions together because I do mix up quite a bit on these ones. Okay. And then I'll give you the AC after we've done this. So if you pay attention, you should be in pretty good shape. Right now we're not after acing, okay? If you ace it, I'm happy for you, it's good. But as long as you're staying in the game and you keep improving and you learn from your mistakes, that's what I'm after right now. Because I know this isn't easy, right? Like for some of you it's just natural, it comes natural. Some of you need to practice and see more, okay? So the odds against smart TV being defective from factory are 20,000 to 3. So the wording is going to throw you off. Obviously, we know it's odds. We all agree with that. But it says against. Against what? A smart TV being defective. Okay? It's a long thing here. But this is the event. Right? That is the event. So when it's odds against event, then technically this number represents that event. So in this particular case, these are defective, and that means that these ones are good ones, right? Like, but I will write it like this: defective not, right? Not defective. That's how I'm going to refer to that. So if the company produces 64,000 TVs per month, how many would be defective in a year? I will make a prediction. And I don't know if you remember, you have to take the probability and multiply it by the large sample. Okay? And here's where you have to pay attention. What's the probability of them being defective? Well, we know 3 are defective out of, remember, you add these up when you get a probability out of them. So make sure you show that. This is my probability of them being defective, and the large sample is 64,000. And I know you may have solved this differently. I don't really care how you do it, as long as you come up with the same answer, because I do know it can be done differently. 3 stays, and the bottom is 20,003 TVs. So when you see the odds here, you're technically considering 20,003 TVs. We're going to multiply that by 64,000. So you go 3 divided by 20,003. It's a very small number. Leave it as is. Multiply that by 64,000. You get 9.598 and something defective TVs per month. Because it says 64,000 TVs are made in a month, right? You would have to multiply this by 12 months because they want to know how much in a year. Okay, so read carefully, and that's why I bolded it, underlined it. So we're going to multiply this answer by 12, and you get 100. I've been having issues with my lead refills. Need to change the brand. 115.18. So that's approximately, you can go 115 or 116 TVs are defective. in a year. So they made lots of TVs, and so that's not really that bad. And that's why they sell you the insurance, you know, and you buy electronics. They're like, hey, you want that extra insurance just in case it breaks down? Because they know how low the chances are of that happening. So if they collect it from everyone, they make extra money, right? It's almost like getting a tip as a waiter. Like you get some bonus money. They know they're going to get to keep it, most likely. Okay. Example, the probability of going blind after laser eye surgery is 1 in 5 million. So remember, this is total because we're talking probability. This is your total. 1 out of 5 million total are end up in the patient going blind. So now it says state the odds. So right away you should think of, okay, of going blind after surgery. So we know that 1, so this is basically, I would ask you to first write down what you're writing, what the numbers represent. This would be blind, and this would be not going blind. Because it says the odds of what? What's the event? Going blind. So blind, not blind. That means that the 1 would go here, and this would be 5 million. I hope that the odds are even smaller than this. I think I just made this up. Oops. Okay. I just want you to know how to work with, I actually try to Google these things, and I don't know how accurate they are. But, so this is odds, right? Going blind, not going blind. This is the definition of odds, guys. You're not comparing to the total. You're going event happening, not happening. Okay. State the odds against going blind. All you need to do, because we're talking about the exact same event, is just flip it. Boom. There you have it. State the probability against going blind. Probability, so we're talking fraction. And so we know the 5 million is going to be in here. There's several ways you can do that. You can go 5 million minus the 1 where someone ends up being blind, right? So this is the probability against going blind. Okay? Remember, something happening up here, 1 over 5 million. Something happening and something not happening always adds up to 1 or 100%. This one represents going blind. So we take that away from our total. So the not, think of not as always subtracting. Always subtracting. If you don't want something, subtract those events from the total, boom, you get the not. Okay? Fun stuff, eh? I know. 23. Okay, this one is going to be on the AC as well, but it's not that difficult. It's basically using what you've already been doing before. Okay, so here we go. The best way to determine higher chances, right? To determine higher chances is to determine the probability as a decimal or percent. Okay? The higher value has the higher chance of happening. So, the odds of being attacked by a shark is 1. Is this the weird one that I need to change? Hold on. I think the number is super, super small. I'll just leave it. Just follow me. The number is going to be super small for one of them, but it still proves the point, okay? State the probability of being attacked by a shark. Okay, so we have the odds of being attacked by a shark, so we would go like this. The first thing I would like you to do is 1 plus, right? You're going to add these. So we add these two numbers. So I basically go arrow, right? I use the odds to come up with my probability, and it's 1 over 3748068. we're going to come up with a decimal. It's going to be super small. We're going to skip the decimal. We're going to go straight to percent. So we're going to go 1 divided by 3748068. Right? We divide it, and then we're going to multiply that by 100 right away to get our percentage. What is that? 0.1234 zeros. I'm just going to write down the whole thing. Everything that my calculator is showing me. That's the chances of being attacked by a shark. So you just go swim away, man. Okay? State the probability of being attacked by hornets. So hornets are up here. Again, we're going to a probability, so you need to get your total of number of instances. So you take the it happening, it not happening, and it's, you know, it's 1 on top in this case. So that translates to this. And we're going to go straight to percent. We're going to skip the decimal for now. 1 divided by 54094 times 100. That is 0.001848633%. Once you wrote it down, I hope you're okay with these. But which one is more likely to happen? This one, right? This one is a bigger number. It's only got 2 zeros here. This one has 4 zeros. So this is a way smaller chance. So bigger chance, right? So being attacked by hornets, since the probability is greater. Okay, that's how you know the probability is greater. That's how you know. You can't see that, can you? Let me just bring that up a bit. It's greater. The odds of Xavier being late is 4 to 9, while the odds of Nina being late will be 5 to 14. Which student is more likely to be late? They may or may not be former students of mine. Anyways, 4 plus 9, right? You add it up, and it's 4. So it's 4 over 13 is Xavier's probability of being late. Let's turn that into a decimal right away. That'd be 0.31 or times 100, 30.77%. Nina being late would be different odds, right? Doesn't matter. 5 plus 14 is our total, and 5 goes on top. That'd be 5 over 19. 0.26 multiply that by 100, that gives me 26.32%. Which one is more likely to happen? Xavier is more likely to be of being late, right? Xavier is more likely to be late since the probability is greater. Is it very likely that he's late? It's less than 50%, so it's not very likely, but it's more likely than Nina being late. Okay? There we go. And I did a bunch of those on page 24. Which one is more likely to happen? The key is posted, so you can check that for yourself. I think I want to do one question on 24 and one question on 25, and then the rest I'll leave that up to you. So go to 24, and I'm just going to do a random question here. I'm going to do C, 24C, this one right here. So go to page 24. Drawing a club face card, right? Which one is more likely, this one or a spinner landing on yellow? You want probabilities. If you're talking club face card, how many are there in total? I hope you know that. 52. How many club face cards? How many? 3, right? The clubs, right, is one suit, and there's Jack, Queen, King of clubs. So 3. So let's turn that into a decimal, because I would like you to know to answer it either as a decimal. So let's do 4 decimals, 0.0577, which is 5.77%. Question? Ace is not a face. Did I say that? I think numbered cards, if it's numbered cards, you take away the faces and the aces to be left with numbered cards. If I said that, if I did really say that, can we fix that? I'm going to go to page 4. In my notes, so I don't know, I may have said that by, I don't know, that was a mistake. I hope you get that. There are only 12 face cards because it's Jack, Queen, King. So 3, 3, 3, 3, that's your 12 face cards. Aces are not face cards. So please change that if I did say that by mistake, just because I do make mistakes, unfortunately for you guys. This is, I'm just going to say probability of CF, right, club face. And then probability of yellow, that is based on this spinner here, which has 8 sections, and there's only 1 out of 8. That is 0.125. That is 12.5%. Okay, so this one is actually more likely to happen than that. Okay. More likely. Okay, 25. Let's go with being struck by lightning. I honestly don't know how they would measure that, but anyways, let's just go with it, right? The odds of being struck by lightning, okay? That's the event. Because it says of, it's in favor, which means the event happening is lightning, and the second number represents not being hit by lightning. State the probability. Sometimes it says state, sometimes determine, sometimes calculate. Calculate usually means you have to do some kind of calculation, like a formula. Stating is easier. The probability against being struck by lightning. Okay, you have to be careful here. I will use this. Probability against, so not being struck by lightning is what they're after. And you know it's probability. So what are we going to do first? We're going to add these two up. First and foremost, add them up, get your total. Because odds do not have totals. And which number, is it the 1 or the 11,000 that I need to put down here? I've determined that this number on the right represents not being struck by lightning, so I can just go ahead and just put that number down. So it's 11,999 over 12,000. Doesn't ask for decimal percent, so just leave it like that. State the odds against being struck by lightning. Oh, it's the same event, and it says against, so guess what? I'm just going to flip it. Out of 850,000 people, how many are likely to be struck by lightning? That's a prediction. You're talking about a really large number, right? So prediction, I'm just going to grab the probability of being struck by lightning. It's a 1 over 12,000, correct. If you caught that, that's all you need to do there. So that's the probability, which is very small. So 70.83. That's a lot of people. That doesn't seem right. Anyways, approximately 70 or 71 people. Cannot be right. But the point still remains, right? The process remains. Okay. Okay. That's all for